Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. As you know, you should have received an email with the individual points for test number 1. I'm going to go through that in a little while. Now, where we stand, we're in good shape for everything. And I just want to remind everybody, which I think most of you have, but in case you haven't, make sure you hand in labs when they're due, please. I think most of you are pretty up to date. All right, what I'd like to do first is today, I'm going to go through the test answers. By the way, thank you, and thank you, because you guys did really good. It makes me happy. See, my heart's doing much better now. It was doing good before, but even better now, because I'm very happy with the results. Now, what I'm going to do is I'm going to go through the whole test. I know everybody did real good. The average was, I forgot, well above 90, which is quite good. But I'm going to go through the whole test. That's my standard operating procedure, otherwise known as SOP. And listen carefully. You should never, ever be penalized for an error I make on grading. If I do, email me, don't ask now. And if we were face-to-face, I'd be saying the same thing. Face-to-face, I'd say, give me back your test. Well, I already have a copy of it, so you don't have to do that. Send me an email, what you would like regraded, and I will regrade it. Now, when it comes to grading, there's a couple things. First of all, organic chemistry tests are hard to give partial credit. In terms of synthesis problems, either did it right or wrong. That's standard. When it comes to nomenclature, if you get the base name wrong, I don't give any points. If you get the substituents sort of messed up, I either give on a 3.1 or 2 points. But let's get going. On test number 1. Hold on a second. There, got it. Well, if I were in your place, I'd have a question. Well, after test 1, what grade am I getting in your class? Well, what's the answer to that? And the answer is the following. I'm going to assume you've handed in all your labs. And based on that, if you got 90 and above, you're getting an A, 80 to 89, B, 70 to 79, C. I think all of you got above 90. Wow. And that's test number 1. Any questions on that? You guys did good. Thank you. All right, let me open something All right, let's go through the alcohols problem set. I'll pick a couple from each page. If there's something you would like me to go through, ask, please do. And, oh, time for a commercial from Dr. White. Don't forget, tonight and Wednesday from 5 to 6:15, I'll have my office hour. If you have any questions, whatever, stop by. Also, last semester, this time worked out good for everybody. If this is not a good time for you, let me know by email. Maybe I can adjust it if everybody wants slightly different time on Monday and Wednesdays. All right, let's go through the alcohols problem set. And the first one is give the Iupac name for the following. And how do you do that? You look for an OH group, or what you actually look for what's different. This chapter and the next one, the one after, look for what's not carbon or hydrogen. Ooh, an oxygen with a hydrogen, hydrox group on a carbon, that's an alcohol. That's not what I want. That's what I want. Remember, hydrox group on a carbon, alcohol. And alcohol nomenclature, find the longest chain or ring with the hydroxyl group on it, name it as alkane or cycloalkane, drop the E, replace it with OL, acyclic, you also need a number, which carbon, the hydroxyl group is on. For cyclic, no number, because the carbon with the hydroxyl group in a ring is always number 1. All right, let's go look and see if I did them right. And also if you haven't. So we have this compound, hydrox group on a carbon, longest chain, 3 carbons, propane, drop the E, add OL, and notice the hydrox group. This is something students forget. You need a number of what carbon it's on, even if it's on the N one. That'd be 1-propanol. Ring with a hydroxyl group, cyclohexane, drop the E's, add OL, cyclohexanol. And if we look at C, longest chain, 5, pentane, drop the E, pentanol, add OL, it's on carbon 2, and the methyl group is on carbon 3. Now for ring, we have 1, 2, 3, 4, 5, pentane, so ring, cyclopentane, drop the E, add OL, cyclopentanol. Now, the carbon with the hydrox group is carbon 1, and then on carbon 2, we have an isopropyl, 3-methyl. Therefore, the correct Iupac using the alphabet rule is 3-methyl, 2-isopropyl, cyclopentanol. If you put down 2-isopropyl, 3-methyl, I would have given you full credit. All right, next one. Draw the condensed structure for the following organic molecules. Now, let me remind you, for acyclic alcohols, I always start numbering on the right. If you want a number on the left, that's okay. And here we have, start from the right, OL ending alcohol, if that were E-pentane, 5 carbons. And where's the hydroxyl group? On carbon 2. Now, if we look at here, OL ending alcohol, if it was an E, cyclobutane, this 4-membered ring, and you could put it on any carbon, the hydroxyl group. And if we look at C, we have 2-octanol, OL ending, if that were E, octane, 8 carbons, whereas the hydroxyl group, carbon 2, and carbons 3 and 5, dimethyl, which is this. Now, when you can't have the hydroxyl group on any other carbon but number one in an acyclic, and there's two cases, and E is one of them, you don't have a number. That's longest chain, two carbons, ethane, drop the E, add OL, ethanol. You can't have two ethanol because it would still be one ethanol. You just made a mistake numbering. Now, do you know what ethanol is? Ethanol is a small little molecule that's found in beer, wine, and hard spirits. You know, the good stuff like vodka. I like my vodka. For those of you who don't know vodka, two best kind, in my opinion, are Absolute and Grey Goose, and I don't get any money from them for saying this. I like Absolute just a little bit better than Grey Goose, and it's a lot cheaper too. But if you got, only if you're old enough to buy this stuff and drink it. If you like vodka, if you go to Costco, they're what they call French vodka, the one with the red at the bottom of the bottle, which is a little more expensive than the what they call American vodka, is this close to Grey Goose and Absolute, and it's a lot cheaper. I didn't say that. And when I used to go to the Netherlands a long time ago, they had a homebrew version of vodka called Genever. There are two types, Neue Genever and Alten Genever. Neue or New Genever was really vodka. Alten Genever was really Scotch, which Dr. White doesn't like. And it was super cheap. And I used to stock up. I'd come home on the plane with 3 or 4 liter bottles of vodka from a company that became Kettle One. And once they got famous, their prices went up. Oh, that reminds me. Next time you're driving by a gas station, take a look at the pump and it says this gasoline, there's a placard, either it's black on white or white on black, and says this gasoline contains up to 10% ethanol. And now you know where's the place you can find alcohol and gasoline. Would I ask a question like that? All right, let's look at some reactions. Give the product or products to the following. We just went through this one in test number 1. This is the only question the whole semester I can put on either test. And that is a double bond, acid and water. Remember, double bond, acid and water. Water is HOH, break the pi bond. One carbon gets H, the other gets the hydrox group OH, and it follows Markov-Nikov's rule. The carbon with the most hydrogens, this end one has 2, gets the hydrogen. This other carbon double bond has 1, and it gets the hydrox group. You don't break carbon-carbon single bonds. And the same thing for B. And C. Wow, I gave you a lot. All right, let's look at F. F, we have what's different, oxygen, look for what's not carbon, what's not hydrogen. Hydroxyl group on a carbon alcohol, sulfuric acid, little triangles like the flame on top of a Bunsen burner, heat. And I don't always, sometimes I do put down 180, high heat. And you really got to heat this to make this go. And what happens is you lose water. Now you can lose the general reaction, which I have up here, hydroxyl group and adjacent carbon with the hydrogen, you form a double bond, and it follows Zays's rule. Now for D and E, you don't have to bother because there's only one place you can lose a hydrogen to form the double bond. But for F, there are 2 places, A and B. And if I lose the hydrogen from A in the hydroxyl group, I'll get structure A. If I lose the hydroxyl group and the hydrogen from B, I'll get the double bond or structure B. Now, Zays's rule is you get the compound or the product that has the most carbon atoms directly bonded to the carbons of the double bond. I'll say it again. You get the product that has the most carbon atoms directly bonded to the double bond carbons. This one has two. The CH3 you don't count because it's not directly bonded to the carbons of double bond. In B, you have this one, this one, this one, 3, which is a greater number, B, and that's the answer. Now, in G and H, we have an alcohol, in this case, a secondary alcohol, and you react, oh, the prime fell off this one R group. Don't look. But anyways, secondary alcohol, hydroxy group on a carbon, O in brackets means oxidizing. I'm being nice this semester. I'm not having you learn all the different oxidizing agents. We just use this symbol for all of them. And you remove this hydrogen and this hydrogen from the hydroxy group, form a carbon-oxygen double bond. And there it is. Same thing for BH. And if we look at, let me move this. This was on the other. I, which the letters on the previous, we have a primary alcohol, you oxidize it, and the same thing happens. You form a carbon-oxygen double bond, which you'll learn later on is called an aldehyde. And that's what happens here. Oh, let's have some fun. You haven't had any fun yet. What would be the organic product or products for the following reaction? And when you're done, give me a thumbs up. I think everybody's just about done. What do we have here that's different? Oh, oxygen with a hydrogen and a carbon, and that's being oxidized. So we have a primary alcohol, and we're oxidizing it. And what happens? You lose the hydrogen from this carbon with the hydroxy group and the hydrogen from the hydroxyl group, and you form a carbon-oxygen double bond. I like to write it this way. If you like to write it this way, that's okay also. I just think this looks cooler, and it is in my mind. All right, so what's my R group? This. Another way of thinking it, I start out with 5 carbons, 1, 2, 3, 4, methyl group there. Here's the carbon with the hydroxyl group. It becomes this carbon, double bond to oxygen with a hydrogen, and there's 4 bonds to carbon. So I put in my hydrogens. By the way, a double bond to oxygen counts as 2 bonds. And that's how you do it. Now, on test number 2, unlike test number 1, I will have 3 or 4 synthesis problems. So let's do one. what would you oxidize to make that molecule? And when you're done, don't forget, give me a thumbs up, or I'm going to try the polling. I haven't done that in a while. All right, I think everybody's done, so I better get to work. Now, if we look at this, the product, what's different? Ooh, carbon double bond to oxygen. It's got carbons here and carbons here. And I don't need that extra prime. And what do you oxidize to make? This you'll learn later on, maybe this week or next week for sure. That's called a ketone. And the answer is a secondary alcohol. I'll never ask you what a primary secondary alcohol is, but I'd like to use it. What's our prime? Ethyl. What's our methyl? And you can have them reversed. So I have my methyl group, my carbon with the hydroxyl group, and then my ethyl group. Now you could have also written it this way. Either way works for me. And that's how you do a synthesis problem. As I said on test number 2, there'll be 3 or 4. I've got to sit down this weekend and write it. It's coming up. All right, let's move on. If we look at J, K, and A and L, same reaction. Let's do K. Dr. White loves rings. We have what's different, the starting material. Oxygen with a hydrogen and a carbon, alcohol. We're reacting with thionyl chloride, and you replace the hydroxyl group with a chlorine on the carbon that had the hydroxyl group. Everything else stays the same. So if you notice, the hydroxyl group has been replaced with a chlorine. And the same thing for L. Now, if we look at M, N, and O, it's the same type of reaction, and that is now alcohol. What's different? Look for what's not carbon, what's not hydrogen atom. Oxygen with a hydrogen, hydroxyl group on carbon, alcohol, reacted with HX. Remember, X can be chlorine, bromine, or iodine. And you replace the hydroxyl group on the carbon that had the hydroxyl group with the halogen from HX. Everything else comes along for the ride. So if you look at M, I did the chemistry instructor's trick on a test, put a big scary molecule, but no, it's not. As soon as you know it's just an alcohol reacting with HX, everything comes along for a ride. The only change is hydroxyl group replaced with chlorine. And the same thing for N and O. Now, because Dr. White's lazy, I realized I should have put another Zayseth's rule problem instead of rewriting and numbering it, lettering it again, I just threw it on the end, which I did. Let's look at P. What's different? You have a hydroxyl group on a carbon alcohol, but we have an adjacent carbon with a hydrogen. And notice I'm reacting with H2SO4, sulfuric acid, heat, very high temperature heat. Remember, the triangle means you heat it up. Now, the general reaction is sulfuric acid and heat. You lose the hydroxyl group and an adjacent carbon. You lose a hydrogen. You form a carbon-carbon double bond. And it follows Zasev's rule, which is the carbon with the most, the double bond with the most carbon atoms directly bonded to it is the product you get. In real life, it's called the main product. You get a little bit of the other, but for my test, I'm making it easier. That's what you get. So if we look, here's the hydroxyl group. On this carbon, I have a hydrogen, I label B. And on this carbon right here, I have a hydrogen A. If I lose the hydrogen from A in the hydroxyl group, I'll form this alkene. If I lose the hydroxyl group and the hydrogen here, I'll form this one. Now let's count how many carbon atoms are directly bonded to the carbons of the double bond. And this one, we have 1, 2. Here are my carbons double bond. In B, we have 1, 2. Don't forget the methyl group. That's called the exocyclic carbon. Exo meaning outside the ring. Students tend to do that. 3. So which has more carbon atoms directly bonded to the carbons of the double bond? A has 2, B has 3. Remember this at my class, Chem 170, has very tough math requirements, which is the greater number. Hopefully I'll pick 3, and therefore B is the correct answer. And that's how you do it. Anybody have any questions on the alcohol problem set? I apologize, I try not to, but once in a rare time, we'll do a test key and a problem set together. I know it's not the most exciting thing, but it helps your grade, which I think is exciting. All right, any questions on alcohols? Going once, going twice. Did anybody happen to go in your bathroom, if you keep it there, and see a bottle of rubbing alcohol and think, wow, that has isopropyl alcohol, an alcohol in it? All right, how are we doing on time? All right, got about, let me just close up something. Now, last week, I finished up, we just started getting into epoxides. And one epoxide I asked you to learn, and we'll talk about, I could do at least 4 or 5 weeks of lecture on reactions of epoxides, but the common name for this is ethylene oxide, and I'll never ask that on a test. And I'll try and be good. I've been good so far. I won't use slang, which is EO. And Dr. White has worked heavily with ethylene oxide at 2 different companies I worked at. Now, the reaction I would like to teach you, there are 2 of them. first of all, this will never be on test, but this is why you never want water in a reaction with ethylene oxide, because the ring is very strained. It wants to pop open, and water will do that. So you have to keep water away from it. But an important reaction is the reaction of alcohols with ethylene oxide. And what you get is this ether alcohol compound, a molecule with two functional groups in there. And this is a very important reaction. I worked for one company that made, I don't know how many million pounds a week, two at least, of this type of reaction with different alcohols. Ooh, I ran into the break. Sorry. It's break time. Come back in 5 minutes. Let me look at my clock again. Come back at 1:56, and I'll see you at 5 minutes. I'm going to go get up and stretch. See you in 5. Let's get back. Sorry about that. I have to go to my kitchen, get a fresh bottle of water from my refrigerator. I keep them in there so they're nice and cold. All right, we're talking about epoxide, ethylene oxide, and reaction of alcohols. And here's the general reaction. And let's do some. And if I were to look at the following reaction, I'll do this one, you know, I'm going to share so you can have fun too. Question is, what's the product or product? What do I have here that's different? Ooh, oxygen. Remember, look for what's not carbon, what's not hydrogen, because that's where the fun is, and action. And an oxygen with a hydrogen and a carbon. This is an alcohol. And I'm reacting it with ethylene oxide. A three-membered ring, 2 carbons, 1 oxygen. And this reacts to give the following ether alcohol. And the carbon in R with the hydroxyl group is the carbon here in R with this oxygen. So what's my R group? 2 carbons. So the product I get would be this ether alcohol. And that's how you do it. Now, one thing on the reactions with ethylene oxide, I will never give them as a synthesis problem in a test or the final. I will ask you give the product or products, but this and the next reaction, I'll remind you, I will never ask in a synthesis problem. So let's have you try one. And here's one for you to try. Enjoy. All right, if you're finished early, please allow everybody time to finish too. When you're done, give me a thumbs up on your monitor. All right, I think everybody's done. So if I look at this reaction, what's different? Ooh, what's not carbon? What's not hydrogen atom? Oxygen with a hydrogen and a carbon. That's an alcohol. And I'm reacting with ethylene oxide. And what do you get? You get this ether alcohol. This H goes on the oxygen, and then this oxygen here goes to that carbon, and you break that bond. But anyways, what's my R group? Isopropyl. Remember, you don't break carbon-carbon single bonds. So that's my R group. Remember, the oxygen and the hydroxyl is on this carbon, so the oxygen of my ether alcohol will be on that carbon, and this is what I get. And that's how oh, this is fun. Remember, I've worked in this area. I've got to have you do another one. And there's another one for you to have fun with. What would be the organic product or products of the following? 3 points each. All right, anybody need more time? Well, first slide. Thumbs up, people. Are you all done? I guess the answer is yes. So I better get to work. Well, if I look at this molecule right here, what's different? What's not carbon? What's not hydrogen? An oxygen with a hydrogen on a carbon, alcohol. And what's this? Ethylene oxide. And what you get is this ether alcohol. What's my R group? And butyl group. So I'll have 4 carbons. Notice the N carbon has the hydroxyl group, which will be the carbon that has the oxygen here. Then I have CH2, CH2, OH. And I'll put in the rest of my hydrogens because I know there's 4 bonds to carbon. And that's the molecule I get. Now, we're getting to the interesting part of this class where we can talk about really fun stuff and sometimes not too much fun stuff. And this new molecule you just made has a Iupac name, which I don't ask you to learn because it has 2 functional groups, but it's called 2-butoxy ethanol. And you take N-butyl alcohol or 1-butanol, react it with 1 molecule or mole of ethylene oxide, and you make that. And the question is, why are you learning this stuff? Well, let's find out. Let me just. That's not what I want. All right, I don't get any kickbacks from this company, but if you notice, it has easy off, fume-free oven cleaner. Now, easy off has 2 different products. One where you heat up the oven and then you spray the stuff on the hot oven or put it in the oven and heat it up. And that uses a very noxious chemicals. They smell bad. And this one, you don't have to heat it up. You just spray it on there. And notice they have caustic fumes. The other product has sodium and potassium hydroxide, caustic meaning base. Now, this one works quite well. I know I've done my oven, I've done my sister's oven, I help her out. And you spray it on there, let it on for a while. Now it says 30 seconds. I let it on for about 10 minutes because the sister's oven was really bad. And If you look at the label, which you can't see here, excuse me, the main ingredient is 2-methoxyethanol. Where did I hear that name before? It's this molecule. And how do they buy it? Some company takes butanol, 1-butanol, and reacts it with ethylene oxide. Actually, I work for a company that did other alcohols, not this one. Now, molecules can be used for many things. Sometimes good, sometimes not good. And now I need to tell you something about where 2-butoxyethanol was used for something that was not good at all. How many of you are familiar with a number of years ago in the Gulf of Mexico, there was a horrendous oil spill from the Deepwater Horizon drilling platform. And let's go to Wikipedia. And it was named after the spill, after the drilling platform, Deepwater Horizon oil spill. And when this happened? Wow, it's almost 11 years ago. And this happened in the Gulf of Mexico. And being an organic chemist, I was wondering what the heck is going on. And I followed this very closely in the news. And it took them a long time to stop the leak. And after a couple of days, while it was still gushing oil underneath the water in the Gulf of Mexico, I did a calculation how much oil is being released from that well. And I found the numbers that the companies were reporting were about half or less of what actually I figured out was probably coming out of there. It was bad any way you look at it. And after a number of days, it was reported in the news that to disperse the oil, because oil and water don't mix, they're not soluble, they used a special chemical called the dispersant. And the chemical they used, or the product they used, was from a company in Naperville, Nalco, which is now, I believe, owned by a French company, and it was called Corexit. And they had two different ones, and 9527, which was the main one, and the 9500, that's their trade name. Now, this is an important lesson I want to teach you now that will never be on a test, but I think is something useful for the rest of your life. Every chemical that's sold in the United States, that's used in the United States, there's what's called the material safety data sheet that has been created by the company making that chemical or product, and that has to be available to the public. And material safety data sheet, the acronym is MSDS. Some people just say SDS, safety data sheet, on the old school MSDS. With the internet, I think just about every MSDS sheet is available. Well, I was raised by my parents to be socially responsible. And I'm an organic chemist, a PhD organic chemist. And back even in 2010, I had many decades experience, with organic chemistry industrially and in the real world. So I'm looking at this and say, what the heck is Corex products? What's in there? They're putting these millions of gallons into the water. I hope it's safe. Well, what did I do? I went to the internet. I looked up the MSDS sheet for Corexit 5297. All you have to put in is, and this you can do for other things if you're ever interested, is that chemical I'm using, this product, dangerous for me? Put in the name, put in the letters MSDS, and you'll find different. And here I'll click on this one. And this is a material safety data sheet. they're pretty much the same, standardized. These are newer ones. The older ones used to be more descriptive. You can guess why they're less now. But anyways, they always have a section 1 product and company, then hazards. Now, they used to have written hazards. They still have some, but the higher the number, 0 is the least hazardous, 4 is the most hazardous. And notice for toxicity, dermal, your skin, inhaling or getting it in your mouth, it's 4. This is nasty stuff. Now, one of the things they have usually is in a section showing composition, if it's not a pure substance. And notice here, you have 2-butoxyethanol, 30 to 60%, which means most of this product is 2-butoxyethanol. Well, you can go to Google and look up 2-butoxyethanol. Here's the trade name or common name. It's also 2-butoxyethanol, the Iupac. And you'll see this stuff is nasty, dangerous. Now, the original MSDS, the older ones back in 2010, had things like how it will kill marine life, real good, putting that into the Gulf of Mexico, and how it's very toxic, what organs in the human body it really, I don't know if destroys the right word, but is quite hazardous too. Well, when I read that, I said, whoa, this is not good. So being the socially responsible organic chemist, I was able to get in contact with the person who was in charge, or number 2 person for the Coast Guard of the cleanup. I said, this stuff is hazardous. You got to stop it. He said, well, why don't you call our chemist who's in charge? I called this guy, PhD chemist, nice fellow, but didn't know what the heck he was doing because he was an academic chemist, an analytical chemist who had no real world experience with dangerous chemicals like I have. I tried to tell him, he said, oh, Nalco is telling us it's not that bad. Well, I didn't stop there. Being a socially responsible chemist, I called MSNBC, CBS, and the New York Times. And I'm sure I wasn't the only chemist. I hope I wasn't doing that. And within a day or so, those news outlets were bothering the government. Why are you doing this? It's hazardous. And finally, they stopped using it. But after putting millions of gallons, every gallon is 8 pounds. So figure half of that is the 2-butoxyethanol. That's millions of pounds of that were put into the Gulf of Mexico. Well, if you followed that, a lot of the shrimping and other industry was really destroyed in the Gulf of Mexico because of Corex. Now, a footnote, a sad footnote. A couple of years ago, I don't know how I got in contact. I think I contacted somebody, I saw their story, and I just told them what I told you. And that person had written a story about Gulf of Mexico's oil spill 8 or 10 years later, 7 or whatever, a couple of years ago. So he said, this writer, can I have someone call you? I said, sure, who? Well, this is a writer who was actually a volunteer helping clean up the oil spill. You know, like they went out in barges, tried to collect the oil off the surface of the water. Those were the people going around cleaning up birds and the shoreline with all the oil coming from the oil spill. So I called that person called me. We were talking, I said, you know, here's what I did. I saw this in the MSDS and I said, that would cause this, this, and this in humans. Also kill off good part of the fish. And the sad story he told me is he worked on a boat, even though he was covering it later on as a story, and also helped in the cleanup. And many of the people he met who worked in that were exposed far more than him were now sick years later with all the things they said in that MSDS sheet. Sad but true. So organic chemicals, they can be used good for good uses and sometimes not that good. Today, one of the things that you can always take away from is if you go to Google and put in MSDS sheet and the name of a chemical, notice here for 2-butoxyethanol, put the name in and hit enter. And here Fisher Scientific is very reputable. And these VWR is a reputable company. And you can find it. And let's see, they say, is it safe? Here they say, may be harmful. No, it is harmful. It can harm the eyes, skin, kidney, and blood. And people are having all these types of problems from exposure. Well, anyways, sorry to bring it up, but it's a true story. Remember, if you ever are concerned about a chemical you're using or in a product you're using, you can always look up the MSDS sheet. All right, now I'm going to do something on the whiteboard. Do not copy it down. Well, if you want to, I'm not going to stop you, but don't. And if we look at the following reaction, what do we have? Alcohol plus ethylene oxide reacts to give an ether alcohol. What's our methyl? So my product will be this. Again, you do not have to write this down, and you'll see why in a little while. Trust me, I'm an organic chemist. Did that work? How about trust me, I'm a doctor? Now, if we look at this new ether alcohol, what if I react it with another molecule of ethylene oxide? Well, I can because we have an alcohol here. And now what's my R group? This. And therefore, what do we get? Here's my R group of this alcohol. And now I get O, CH2, CH2, OH. But this one, this molecule now right here, I can react with another molecule of ethylene oxide. Sort of like the Energizer bunny. I can keep on going on and on and on. Well, here, what's our new R group in this alcohol? This. That's now my R for my general reaction. So I'll have CH3, O, CH2, CH2, another O, CH2, CH2. And now what I'll add is this. O, CH2, CH2, OH. Now, there's an easier way to write this. Up to now, I've stayed away from it. That's writing something that repeats in parentheses. Notice that's 1, that's 2, that's 3. And it's the same OCH2CH2. And therefore, I can rewrite this, being a lazy organic chemist. Here's my repeating unit. I'll put it in a bracket, subscript right side. That should be a 3. How many times did it repeat? 3. So this is how I could write it also. Number 3. Let's look at something interesting. How many molecules or moles of ethylene oxide did I react with my original alcohol? 1, 2, 3, which corresponds to this number. And therefore, it's time to talk about how you can react an alcohol with more than 1 mole or molecule of ethylene oxide. In this case, I use 3 moles with molecules. And if we go back, and look at the reaction, if I have N moles of ethylene oxide reacting with an alcohol, I get this polyether alcohol. And notice I have the bracket here, and N here is equal to the number of molecules or moles of ethylene oxide, just like I had before on the previous page. So this is a way of making very interesting molecules. Now, these polyether alcohols find their way in a lot of products you use in your daily life, like a lot of your hair conditioners, shampoos, and other personal care items. So let's take a look at this. So the reaction above, if I had asked, give the product or products, and if I look up here, what's different? An alcohol. Ooh, I have a number here, N molecules of ethylene oxide. And the way you write the product is R, then bracket, OCH2, CH2, close bracket, N, OH. Now, it's important that the hydroxyl group is not inside the bracket. Common mistake on test 2, students put that there. And no molecule exists like that. It's on the outside of the bracket. Wow, why did my pen change colors? I don't know. But anyways, so what's my R group? This. I have my bracket, OCH2, CH2, OH, and then my N group in this case would be 3. Now, I've worked with companies where we use N up to 50. I've worked in labs where, and those are for common products. We've done experimental ones N up to 100. And it's time for you to have some fun. And this reaction, the previous one, I'll never, let me change that. I'll never put a synthesis problem on, but I will put these. And your turn. What would be the product or product for the following reaction? All right, I think everybody's, oh, maybe not. Everybody done? Give me a thumbs up again. Uh-oh, everybody's done. I better get to work. What do we have here that's different? Oxygen with a hydrogen on carbons. This is an alcohol, or this is my R group. Ooh, number 8, which I'll just call N, and ethylene oxide. And you get this polyether alcohol. Remember, N is on the outside, so is the hydroxyl group. What's our 3 carbons? And the carbon with the hydroxyl group is carbon bonded to the first oxygen in the bracket, or the oxygen bracket, CH2, O, CH2, CH2, closed bracket. What's N? In this case, 8. And that's what you get. Oh, I like these. I got to do another one. And here's another one for you to do. Give the organic product or products 3 points each. All right, everybody done? Let's take a look at this. What's different? What's not carbon? What's not hydrogen? Ooh, oxygen with a hydrogen on a carbon, alcohol. And we have, ooh, number 6, I'm going to call that N, and ethylene oxide. And what you get is this polyether alcohol. Remember, the hydroxyl group is outside the bracket. And what's our, this ring with a methyl group? So I'm going to have that ring with a methyl group. Which carbon has the hydroxyl group? This one, which is this one. That's bond to OCH2, CH2. What's N? 6OH. And that side, oh, I got to do one more. Let's just do one more. Now, what I have here, our group, that's 9 carbons in a straight chain, like methyl, ethyl, that's called nonal. I have a benzene ring with a hydroxyl group. Now, let me give you some important lesson in organic chemistry. This is ethylene oxide. I know of no reaction of ethylene oxide with a benzene ring, but I do know of a reaction with an alcohol. And with that, I'm going to let you see if you can get this right. What would be the organic product or product for the following? And when you're done, answer the poll, or you can give me a thumbs up. All right, I think everybody's done. So let's take a look at this. Again, ethylene oxide will not react with a benzene ring, and definitely not with an R group, but will with an alcohol. And what do we have? Alcohol plus 9 and moles of ethylene oxide. And what you get is this polyether alcohol. What's my R group? This. So I'm going to rewrite it. Bonds in the benzene ring are still going to be there. The 9 carbons and the hydrogens are still going to be here. Then we'll have this go to O, CH2, CH2. What's N? This number, in this case, is 9. And a hydroxyl group. And this is what you just made. Now, as I said earlier, one of the questions you should always ask, why am I learning these things? What good is it to me? Well, let's find out. But before I do, I have a little something I want to speak about. Can I have everybody's attention? I'm going to be talking about a lot of interesting things that deal with organic chemistry. In no way am I taking a moral stance for or against something I'm talking about. I'm just talking about the application certain organic molecules are used in our daily life. And as we get on the semester, I'll be able to do this more and more. Well, let's look at the molecule you just made right here. And that molecule has a trade name, nonoxyl 9. It comes from nonoxyl, this C9H18R group, H19R group is called the nonyl group. And the 9 comes from 9 moles of ethylene oxide. Now, this is called a surfactant, and I'll talk more about surfactants. Surfactants are molecules that interact at the surfaces of 2 different things that normally wouldn't react with it or interact. And one of the uses for this molecule is a spermicide. What? Well, let's go and everybody see nonoxyl 9? Over here, they're using the line method. And here is the R group. Every bend in a line is a carbon. So this is 8 carbons at the end of methyl 9. Here's our benzene ring. Then over here is our O, CH2, CH2, close bracket, 9 hydroxyl group. This is a shorter way. I don't use this line method for acyclic carbons because students get confused. I do when I'm talking to my colleagues, but not for you because I want you to learn, not get confused. Well, nonoxyl 9 is a spermicide. And where's the one place you find it the most? And I should tell you, I wouldn't call it a hobby, but a curiosity. When I see something being sold on TV, advertised or anything, if I go into a big box store or other places where they sell it, I'll go over there and look at what are the ingredients, because I'm an organic chemist and I understand that. And where do they use nonoxyl 9? On condoms. in lubricated condoms, if you pick up a box, you can go to Walmart and do this in other places like Target, that French place also known as Target. But anyways, that was a joke of a friend of mine. He uses all the time. You look on the box and it says contains nonoxyl-9 spermicide. So that molecule is as a way of killing sperm. How? Don't know. I'm an organic chemist, but I know how to make it. You do too. Take nonylphenol and react it with 9 moles of ethylene oxide. Now, one of the things I found interesting, it's also used in cream for cervical barriers, which is another type of contraceptive. Now, what I found interesting is it's also used as a lubricant in shaving cream, which explains why men's faces, I guess, don't get pregnant. And finally, one of the most interesting things, it's used in a product to help you if you have poison ivy, and it helps get the chemical that gives you the rash and irritation, like you want to rip your arms apart, out of your skin, and that's the use, and that's nonoxyl-9. But you never thought I'd get into those things in this class. Well, guess what? We can, and I will get into a lot of very interesting things. Oh, let's do one more of those. They're so much fun. And here's another reaction for you to try. What would be the organic product or products that are following? And I think last week I talked about I worked for a company then called PPG Mazer in Gurnee, Northeast, a couple miles, Great America. And the plant next door to the research center, they had million-pound tanks of ethylene oxide. They had 2 of them. I don't know how many million pounds they had stored on site, lots. Because they used a lot, this type of reaction, reacting alcohols with ethylene oxide to make compounds that were used mainly when R is quite large, 10 to 20 carbons, for personal care items, hand lotions, shampoos, conditioners. Those molecules were sold to companies that use them. All right, anybody need more time? I guess not. Let's look at this molecule. What's different? Carbon with a hydroxyl group, alcohol. Ooh, I've got 11. That means N moles of ethylene oxide. And you get this polyether alcohol. And what's my R group? A T-butyl group, so I'll write it. Which carbon of the T-butyl group has the hydroxyl group? That will be the carbon bond to this oxygen in here. Remember, to the right subscript, N is the coefficient in front of ethylene oxide, and then the hydroxyl group is outside the brackets. That's a common mistake students make. They put it inside, and no molecule like that exists, and I mark it wrong, because it is. And that's how you do it. Any questions on that? Ethylene oxide reactions are really neat. I worked at 2 companies that did that reaction. Now, if you look at the slides for this chapter, I don't know if you can see in the lower left-hand corner, page 10 of 10. Guess what? We're done with the ethers, ethylene oxide, or epoxides chapter. Now, next Monday, I will go through the ether ethylene oxide practice problems. I highly recommend that you do the problems before I do it. Now, not to scare you, but tell you the truth, historically, test one, which you guys did real good, is normally the highest average of the semester test. Test two, not always, last semester it wasn't, but most of the time it is. Test two is the lowest average, but prove me wrong like last summer did. Study hard, do the practice problems. Well, if we're done with that chapter, you know what time it is? It's time for a new chapter and new functional groups. Now, I have to warn you, if I look at the time, I'm going to give you a cliffhanger. I'm going to talk about my warning right after our break. Let's take a 5-minute break. I'll see you at 2:50. I'm going to get up and stretch. I'll see you in 5. I'm back. Let's get started. Everybody back? Sorry about that. I went and got my mail. And whenever I bring the mail, since the pandemic started, afterward, I wash my hands, even though I should be safe. I'm not taking any chances, especially with the Delta variant. By the way, public service announcement. Hope you're all wearing like that, your mask when you go out in public. And I hope you all have been vaccinated. I got mine a while back last April. And I'd say sometime in October, I'm going to find out, because I'm in that age group that can, about getting my Pfizer booster. I'm not taking any chances. In fact, sad note, not that sad, but it could have been worse. At the other school, one of my students told me privately, he was tested positive for COVID-19. Luckily, he had his vaccination shots. So yes, he was sick for a couple of days, but he never had to go to the hospital, thank God, and never got really sick. So make sure if you don't, get a vaccine. All right. I left you with a cliffhanger. Everybody know what a cliffhanger is? Like on TV programs, they used to do it in the movies, Saturdays, where you end with, uh-oh, what's going to happen to the hero or heroine? Well, here's my cliffhanger. It's a new chapter time. And the new chapter that I like to talk about are aldehydes and ketones. Now, what was the cliffhanger? If it looks like I'm having way too much fun talking about aldehydes and ketones, I am. Why? Because my PhD thesis was dealing with aldehydes and ketones. My first US patent dealt with aldehydes and ketones. And my last US patent dealt with aldehydes and ketones. I'm a world authority on aldehydes and ketones. Now, how much do I like aldehydes and ketones? How many of you have ever heard of comfort food? Any of you heard of comfort food? You know, if you're not feeling good and you want to pick me up, eat something that makes you feel good, comforting. You know, for me, dangerous comfort food are like the sour cream and onion Lay's potato chips or Doritos and a few other things, which I don't need like a hole in the head. But sometimes, a lot of times, if I'm not, I want to pick me up, I'm sort of in a blue mood, I have comfort functional groups. Yep, now you know I'm an organic chemist. And the top of my functional comfort functional group is aldehydes and ketones. By the way, Dr. White and Mother Nature love aldehydes and ketones. What's an aldehyde? What's a ketone? Well, the aldehyde functional group is a carbon double bond with oxygen with a hydrogen and R group attached to it. Notice I show the bond angles here because a carbon and double bond has a 120-degree bond angle. You don't have to if you don't want to. And this is one way of writing an aldehyde. Again, an aldehyde, carbon double bond to oxygen with a hydrogen and an R group attached to it. And we call that an aldehyde, and I love them. Now, there are other ways you can write an aldehyde. One is where you don't show this carbon right here. And if I were talking to my colleagues, this is the same as drawing this molecule. But I try and stay away from this because it's better for you, but once in a while it slips out. Now, another way of writing an aldehyde, which you may see on the internet, is like this. And that's R, carbon with a hydrogen, and it's double bond to oxygen, but you don't show the double bond. And sometimes you might even draw it this way. Now, I usually do not draw it this way or this way. Why? Well, it's preference. I just think this way looks way cooler. And I like to be a cool dude. So I like to draw it that way. You draw it this way without the carbon double bond showing, or this way, any of those ways is okay. And these are aldehydes. Again, carbon, double bond to oxygen. It's got a hydrogen and R group on that carbon that's double bond to oxygen, aldehyde. Now, another functional group that's similar but not the same is a ketone. And a ketone is carbon double bond to oxygen, but now instead of an R and an H, you have an R and another R group. And I'll call that R prime. That's like X and Y, and R prime can be the same or different. Now, again, you can have where you don't show the carbon and just do a line like that. And those are the two main ways of writing a ketone. By the way, ketone is not spelled with a Y, even though I know students like to do that. By the way, on my tests, I don't take off for spelling errors like that. So we have the two molecules. Now, later on, and I should have a C here. I will realistically write ketones and aldehydes like this. And when R prime is hydrogen, it's an aldehyde. When R prime is carbons, like alkyl group or aryl, meaning a benzene ring, it's a ketone. So we can have ketones and aldehydes, and you can write them both, because it turns out a lot of the chemistry, they react the same way. So being a lazy organic chemist, we found a way of writing both at the same time. So let's just review. Carbon double bond to oxygen with a hydrogen and an R group. This is an aldehyde. Carbon double bond to oxygen with two R groups, R and R prime. This is a ketone. And if you see the smile on my face, I'm already feeling comforted by Dr. White loves aldehydes and ketones. And what I do is I think about some chemistry I can do with them, and that always makes me happy. Aldehyde, carbon double bond to oxygen with a hydrogen R group. Ketone, carbon double bond to oxygen with an R group and R prime. They can be the same or different. Remember, R is anything with carbon and hydrogens in it. Now, one of the most important things, in my personal opinion, in organic chemistry is the carbonyl group. I'm going to be subtle today. Know this. And what's the carbonyl group? The carbonyl group is a carbon double bonded to oxygen atom. And both ketones and aldehydes have a carbonyl. That's the carbonyl group. It is not a functional group like an alcohol, ketone, aldehyde, double bond. It's found in many functional groups. Oh, look, I have it here. Those call the group. The carbonyl group is not a functional group, but is found in many key functional groups. Ooh, let me give you a coming attraction. Everybody, touch your skin. Go like this. You're touching carbonyl groups. Your skin is held together by carbonyl, not ketones and aldehydes, but other things. So is my hair, what's left of it, my beard. And those are all carbonyl groups. And in, how should I say this right? If somebody were to come up to me and ask, Dr. White, what kind of chemist are you? And if I was truly being honest with them in my heart of hearts, I am, and I'm very proud of this, I'm a carbonyl synthetic organic chemist. And what most, not all, but a lot of the work I've done in industry, and also for my PhD thesis, dealt with the carbonyl group in ketones and aldehydes, and also other functional groups I'll teach you. And I am a carbonyl synthetic organic chemist. Now, hold on. I got everybody's attention. You should know how to draw and how to describe with words a carbonyl group. And how do you draw a carbonyl group? Carbon double bond oxygen with two bonds coming out from the carbon. How do you describe it? The carbonyl group is a carbon or carbon atom double bonded to oxygen. And you should know this. You should know how to draw a carbonyl group, and you should know how to describe with words what is a carbonyl group. And again, a carbonyl group is a carbon or carbon atom double bonded to an oxygen or oxygen atom, and this is how you draw it. You should know this. In my personal opinion, there's nothing more important in all of organic chemistry, but then I'm biased because I'm a carbonyl synthetic organic chemist. And if you look at a ketone and an aldehyde, let's look at an aldehyde. Let me go to my whiteboard. If you notice a ketone, an aldehyde has a carbonyl group in it. Remember, carbonyl is not a functional group, but it's an important thing found in many functional groups. So an aldehyde has a carbonyl group. And a ketone has a carbonyl group. Now, one terminology that I will use a lot, because I'm a carbonyl synthetic organic chemist, I love aldehydes and ketones. The carbon double bond to oxygen in an aldehyde and a ketone, I will call the carbonyl carbon. And when I'm talking about the carbonyl carbon, I'm talking about this carbon right here in an aldehyde. And notice a ketone also has a carbonyl carbon or carbon atom. Again, it's this one right here, the carbon that's double bonded to the oxygen. So we have a carbonyl group. You should know how to draw it. Carbon double bond to oxygen. and how to describe it with words. Carbon, double bonded to oxygen. And Dr. White and Mother Nature love carbonyl groups. They are so handy and useful. All right, let's move on. Now, how do you name an aldehyde? Well, first of all, let's put an aldehyde on the whiteboard. Now, because the way I learned it, I'll always write my carbonyl for an aldehyde or ketone the farthest to the right, not on the left. But if you want to put it on the left, be my guest. All right, now let's look at this molecule. What's different? Oxygen, double bond to carbon. It's got a hydrogen and carbons on this carbon. And this is an aldehyde. Again, carbon, double bond to oxygen with a hydrogen carbons. It's an aldehyde. Well, how do you name this aldehyde? Well, guess what? Iupac has rules for that. And first of all, find the longest carbon chain I have here, which includes the aldehyde. And I could have also said find the longest chain of the aldehyde that has the carbonyl carbon in it. Carbon double bond to oxygen. Name that chain as an alkane. Then, because it's an aldehyde, you drop the E at the end of alkane, A-N-E ending, and replace it with A-L. So this E becomes an A-L. And then, first of all, the carbonyl carbon is in an aldehyde always number one. Carbonyl carbons rock, and Iupac know that. So they're always the highest priority in an aldehyde, and therefore you don't have to put that number down because everybody knows it's number one. And all the other substituents like a methyl or everything is named by a number and the name of the substituent in the front. So let's go through this again. Find the longest chain that includes the carbonyl carbon, carbon double bond to oxygen, and name that as an alkane. Drop the E at the end of the name of the alkane and replace it with Al. Carbonyl carbon is always number one, but you don't put that number down, but you remember it. And any other substituents you name as per the Iupac rules we've already done. So if we look at this, we have an aldehyde. How many carbons longest chain? 1, 2, 3, 4, 5. That's pentane. It's an aldehyde. So I drop the E and add Al. And I'm done because this is going to be carbon number one. And I do not put a number like 1 pentanal. That would be wrong. And you're done. Now, important thing, can I have everybody's attention? Alcohol has a OL ending. Aldehydes, I can spell it, has an AL ending. On test number 2 in the final, make sure when you're writing names, you have your OL looking like OL, make it a little bigger, and your AL looking like AL. You don't want me guessing because I can be 50% wrong, which is not a good thing. Is that an O or an A? And sometimes I really didn't know. All right. Remember, find the longest chain with the carbonyl carbon, carbon double bond to oxygen, name it as an alkane, drop the E, add AL, and no number, but the carbonyl carbon, carbon double bond to oxygen, and aldehyde is always number one. All right, let's look at the following molecule, but first I'll give you time to write it down. Am I being nice today or what? Be quiet, Dr. White. All right, let's take a look at this. What's different? What's not carbon or hydrogen atom? Oxygen double bond to carbon with a hydrogen R group or carbons. And this is an aldehyde. And I'll do this one, then I'm going to let you have some fun. And how many carbons in the longest chain? With the carbonyl carbon, carbons double bond to oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Hopefully all pick 7 was longest chain. And 7 is heptane. And it's an aldehyde. So I drop the E and add AL. And I'm going to write it so Dr. White can read it on the test. And as soon as I say heptanal, that's all spoken for. Oh, look what's all left over. It's your good buddy now, the methyl group. Remember, you don't use a number for where the carbonyl carbon is. It's always going to be 1 in an aldehyde, but that's always carbon 1. Therefore, the methyl group is on 5. And we have 5 methyl heptanal, and that's how you do it. Now it's your turn. And why don't you try this one? What would be the Iupac name for the following molecule? And when you're done, don't forget to give me a thumbs up. All right, everybody's done. What's different? Ooh, oxygen, double bond to carbon with a hydrogen and carbons on that carbon, double bond to oxygen. And this is an aldehyde. And how many carbons the longest chain? 1, 2, 3, 4, or 1, 2, 3, 4, 5. So that's pentane is the longest chain. And you drop the E and add Al. Carbonyl carbon, carbon double bond to oxygen is 1. On carbon 2, we have an ethyl group. Remember, you don't put the number 1 for where the carbonyl carbon is in an aldehyde. Oh, let's do one more. These are fun. Again, the question is, give the Iupac name for the following molecule. Looks like a couple of people are done. All right, looks like everybody's done, so I better get to work. What's different? Ooh, oxygen. Remember, look for what's not carbon or hydrogen, and double bond to carbon with hydrogens and carbons. And what do we call that? An aldehyde. And you find the longest chain with the carbonyl carbon, carbon double bond to oxygen. Well, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, or 7, 8. So the longest chain is 8 carbons, and that's octane. But it's an aldehyde, and it has an Al ending. So I drop the E and add Al, octanol. Now I have on there, two methyl groups. And remember, the carbonyl carbon, carbon double bond to oxygen is always 1, 2, 3, 4, 5, 6, 7, 8. And notice I have 2 methyl groups. Remember, di means 2. And it's on carbons 4 and 7. So that'd be 4,7-dimethyl octanol. Now, there's one special aldehyde that Iupac, in their infinite wisdom, since the name had been around for so long, they said, oh, we're not going to change these organic chemists. We're going to make the common name the Iupac name. And that's this one. When R is a benzene ring, it's called benzaldehyde. We talked about that earlier in the lab, and you should know that if I draw the structure and ask what's the Iupac name, it's benzaldehyde. Or if I give the name, draw the structure, it's benzaldehyde. And benzaldehyde is responsible for the key ingredient in the smell of cherries. I don't know about the taste. And it's also a key ingredient in the smell of almonds. And I think I mentioned this before, but I'll mention again. If you, I like Dr. Pepper. I'm a Dr. Pepper person. And when I smell that, I immediately smell the cherries in there for flavoring. And I smell and think of benzaldehyde. I also like things to drink. No, I'm not an alcoholic, but I like my liquor. And if you've ever had amaretto, that's a liqueur that tastes like almonds. And when I smell amaretto, I think of benzaldehyde also. Now, there are two skills in nomenclature. One, here's the structure, give the Iupac name. The other one is, here's the name, give the Iupac, draw the Iupac structure. And it's time for me to introduce you to a very old friend of mine, and that's this one. And I'm going to let you try this all on your own. Draw the structure for 2-ethyl hexanal, a very old friend of mine. Yes, molecules can be your friends. They can also be your enemy too. All right, I think everybody's done. Let's take a look at this. How do we decode this? Go from the right, move left. AL ending, aldehyde. And if that were an E, hexane is 6 carbons. Now I'm going to always put my aldehyde on the right. You could also do it on the left. But for my answer keys and this, my habit, good habits, I don't change. This is the aldehyde. Now, as we move this way, on carbon 2 is an ethyl group. Carbonyl carbon is 1, here's 2. Oops, extra hydrogen. Got it. And that's 2-ethyl hexanal. Now, why do I call this an old friend of mine? Because I use this molecule to make molecules that nobody else could. And that was my first US patent, using 2-ethyl hexanal. And like I said, say hello to my old good friend of mine. Oh, let's do another one. And why don't you draw 3-T-butyl nonanal? All right, I think everybody's done. How do you decode this and know what to draw? You start from the right and move left. AL ending. That's an aldehyde. Remember, carbon, double bond to oxygen, carbonyl group with a hydrogen R group. If this were an E, no name, 9 carbons. And at the end carbon, I like to do it on the right. You could do it on the left. I have my carbon, double bond to oxygen with a hydrogen, the carbonyl group. That's always carbon 1, 2, 3. What do I have on carbon 3? A T-butyl group. And now I know there are 4 bonds to carbon. So I'm going to start writing in my hydrogens. And that would be 3-T-butyl nonanal. That's a mouthful. And that's how you name aldehydes. So anybody have any questions about how to name aldehydes? Well, in that case, let's move on. Let's talk about ketones. Now, ketones, there's something a little different. You cannot have an aldehyde in a ring. You cannot, it's impossible to have an aldehyde in a ring. But in a ketone, you can have both cyclic and acyclic ketones. And here you find the longest carbon chain or ring. Uh-oh, what just happened? There we go. That contains the carbon double bond to oxygen. And you name that chain or ring, I really should have, as an alkane or cycloalkane. Now, for a ketone, drop the E at the end of ANE ending for alkane or cycloalkane and replace it with ONE. For some reason, this is going to be rare, so listen carefully. I'll never say replace it with one, the word one. I always say ONE. Habit of mine. And good habits I won't break. Now, note, the carbonyl carbon is given a number in front of the alkane name, just like you do alcohols, and it has priority in the numbering. However, and I don't have there, in a ring, the carbonyl carbon is always number 1 because they rock. Carbonyl carbons are the best. Now I'm being very biased. Well, I should be. I'm a carbonyl synthetic organic chemist. And then the name and number of the rest of the substituents as per Iupac rules for substituents. And the question would be, give the Iupac name for the following molecule. So I'm going to look for what's different, what's not a carbon-carbon single bond or carbon or hydrogen atom. Ooh, oxygen has double bonds as carbon. Notice I have carbons here and carbons here, and they're different. So I have a ketone. I can spell it right. And now, what's the longest chain that has the carbon double bond to the oxygen? also known as the carbonyl carbon. 1, 2, 3, 4, 5. That'd be pentane. Drop the E, add ONE, pentanone. Now, since this is not in a ring, I need a number. And what is the lowest number I could have? The carbonyl carbon. If I start from this side, it's on carbon 2. If I start from the other side, let's find out. Be 1, 2, 3, 4. And you always give the carbonyl carbon the lowest number because in the Iupac rules, it has higher priority than alkyl groups or anything else. Now, what I won't do in this class, but I do know how to do, is when you have other functional groups, those get numbers too, like an alcohol or double bond, but the carbonyl carbon is always going to get the highest priority, lowest number. Then notice 2 is less than 4, so that's why that's 2-pentanone. And if you have alkyl groups, you name them the same way. And why don't you try this one? What would be the Iupac name for that molecule? I see one person done. I think I see 2. I think everybody's done, so let's get going. Look for what's different. What's not a carbon or hydrogen atom? Oxygen is double bond to carbon. Notice I have carbons here and carbons here. It's a ketone. Remember, Dr. White loves ketones and aldehydes too. And here, what's the longest chain with the carbonyl carbon? Carbon double bond to oxygen. Well, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. And I think 5 is less than 6. 6 is the longest chain, hexane. It's a ketone, which has an ONE ending. Therefore, I drop the E and add ONE. Now, what carbon is it on? If I start numbering from this side, it's on carbon 3. If I go the other way, it's 4. Which is the lower number? Hopefully you all pick 3. So it's 3-hexanone. And on carbon 4, I have a methyl group. So that'd be 4-methyl-3-hexanone. Now, let's take a look at rings. And if you look at this molecule, what's different? You have an oxygen double bond to this carbon. And notice I have carbons here. I'll call R, carbons here. I call R, they could be same or different, but in the ring, R and R prime are connected together. So this compound is a ketone. And Dr. White and Mother Nature loves cyclic ketones. Students don't. How do you name that? Well, the ring is your base name, cyclo, and there are 5 carbons. Every bend in a line is a carbon, and that would be pentane, cyclopentane, but it's a ketone, so I drop the E and add O-N-E, cyclopentanone. Now, everybody knows in a cyclic ketone, the carbonyl carbon double bond to oxygen will always be 1. And therefore, you don't put a number there because it's always going to be 1. Everybody knows that, and you do too now. All right, let me do another one for you. And the question is, what's the Iupac name for the following molecule? Well, if we look at this, what do we have? We have a ring where we have this oxygen double bond to carbon in the ring. And on this side and this side, I have carbons. So I have a ketone. And how many carbons in the ring? 6. 1, 2, 3, 4, 5, 6. And therefore, that's cyclohexane. You have a ketone, so you drop the E, add O-N-E. Now, the carbonyl carbon of a ketone is 1. Everybody knows that, so you don't put a number there, unlike an alcohol too. And then on carbon 3 here, I have an isopropyl. So that would be 3-isopropyl cyclohexanone. Remember, for a ring, you count how many carbons, give the Iupac name for that ring, cyclohexane, because it's a ketone, you use the O-N-E ending, and then on carbon 3, the carbonyl carbon is always 1, and on carbon 3, we have an isopropyl. So that'd be 3-isopropyl cyclohexanone. Now, if I look at the clock, boy, time flies when you're having fun with ethylene oxide and ketones and aldehydes. Wow, this time just went zoom. I hope it does it for you. All right, important things. 1, tonight at 5 to 5:15, 6:15. I wish it was 5:15. No, it wouldn't help you. 5 to 6:15, I'll have my office hour. If you have any questions about anything, or if any way I can help you, stop by. Also, this semester is a little different than last semester. A lot of people stopped by. This semester, not that many. If you think a better time might be helpful to you personally, email me. And don't forget, wear your mask out there. Also, if you haven't been vaccinated, get vaccinated. With that story I told you earlier, I found out last week about my student at the other school who came down. We're Zoom, so there's no contact, but he was grateful that he had gotten his vaccine. And with that, I'm out of time. Gang gesund. Bye now. I'll see you on Wednesday, unless you come to my office hour tonight. Gang gesund. Bye now.